Okay, for people who are joining this live stream, this is one of a long series of meetings talking about how to polish functions in Wolfram language which have been experimental, that might be considered part of the permanent language going forward. And since we like to maintain compatibility so far for like 30 years, we are trying to be quite careful about what we de-experimentalize. All right, so our first topic is quite a big one. It's about our neural net framework. And we've got tons of functions here, but where should we look to understand the bigger picture? Sebastian.
Sure. So I guess the bigger picture is there's different classes of functions here. So one are layers.
Well, so should we be looking at this page?
Sure, yeah, exactly.
Okay. Is anything non-experimental on this page of the neural net stuff? The stuff. Okay, so the higher level functions which use neural nets are non-experimental, but the functions which are the low level representation of neural nets are considered experimental, yes?
Exactly.
Okay. And what is your proposal about what to do?
So the proposal is that all the layers are going to be de-experimentalized with the understanding that the design will change in certain ways for 12. So the main design...
Then why the heck are we de-experimentalizing them?
Okay, well, that's something that...
I mean, why are we doing that? Well, if they're going to change, then they should be experimental.
Sure. So,
yeah, but after 12, you say they won't change anymore. That's what
exactly.
Oh, okay,
so
fine.
The claim is that there's one more change, and after that...
All right, so what is that proposed? So let's take a typical layer. Let's take linear layer, for example. Fair?
Sure.
Let's talk about what... I mean, the thing that continues to bother me somewhat about this design is, this is a story of symbolically represented tensors of various kinds. And, to me, it's not obvious. I mean, these are very kind of minimalist representations of tensors. And I guess my question is, how does this relate to other kinds of, symbolic tensors? I mean, there's nothing particularly... Okay, so I mean, if I say net initialize of this, okay, what is that saying?
So if it doesn't know what the input size is, then it doesn't know how large the weights are going to be. So if you say input goes to 2 or something.
It's not my favorite. I mean, so the question is, why is this not? Okay, fair enough. Dandy. Okay, so what is your statement about these?
Okay, so I guess the major issues at the moment with this, so the first thing is that it needs to have type for the output. So we want to, we can take in like a list, but we really want to make that all the layers output the right type. So if you're doing...
What the heck is this? What is this here?
Okay, so these are internal tensor symbolic tensors.
Okay.
So there's a type system.
It's a type, yeah. It's
exactly
information about the input type.
Okay, but so how does this relate to the type system that Jose has been building and that Tom has been building?
It does not relate to that.
Why not?
So it's a completely separate type system.
Yeah.
That is a question that Tally would be good for. He wrote this type system.
Okay. Well, it seems to me that's a question we need to answer because, I mean, to my understanding, basically this is a representation of some, function that, I mean, what will be the analog of this, independent of neural nets? Just thinking of this as the idea that we have, a net chain where we can, for example, let's say we take line 18, let's say we take table of 18 5 times, for example. By the way, we've got a bunch of background noise that we shouldn't have. Okay, so if I say 5 5, for example, this will
that'll work.
That should work, and that should give us a great big thing that is a series of these linear layers, right? I mean, if I were to say 2, 2, then I could make a nice little plot, presumably. But I'm trying to understand what the analog of this is, independent of, I mean, in other words, if we would just think about this as, okay. If we were to just think about this thing as a series of functions, right? There's a composition of functions of some kind. What is the relationship between this net chain and a just generic composition of functions, which is what we talked about even, you know, multiple years ago before we started building all of this stuff? Do you understand my question?
Yeah. So it is just a composition of functions, except that these things have learnable parameters on them as well.
I understand. But so, you know, as things move forward, right, what's learnable becomes what, you know, the space of things that are considered learnable gradually increases. So, I mean, these are functions with presumably, I mean, these particular things have weights which are somehow learnable. Yes?
Correct, exactly.
And, you know, if we tried to say, take this thing and we tried to say net train, you know, let's just do something just to understand it. Let's take random sample of resource data of MNIST. Oops, comma 500 or something. Okay. By the way, how are we doing it at making all these progress indicators consistent? Have you finished your work with that?
I've not been involved in that at all.
Who has been working on that?
It's the resource system, so Bob.
Really?
I think so, but I'm not 100% sure.
So obviously it can't do that because it's not expecting images. Okay.
Yeah, so there's multiple problems there.
Yeah, right. Okay, but be this as it may, I'm still trying to understand the relationship of this thing. I mean, you know, a lot of this is nice and quite ergonomic for the current phase of the neural net world. It is unclear to me whether it's, you know, built for the future. It's also unclear to me what the future of the neural net world is going to be, in the sense that.
So I guess, yeah, we have plans exactly for that. So basically,
let's talk about it.
Things are becoming more sort of functional based definitions, so that you basically would write a program with variables and the whole program is differentiable. So the sort of syntax for other sorts of frameworks like PyTorch is what we also want to copy. And so the idea for that would be that there'll be some sort of scoped construct. So the current proposal is net function. And inside net function, you can basically, you know, your layers will be like in the module in the.
Yeah, okay. But so what these are like lambdas. What we have right now are things, and what you are proposing is something where we have named variables hanging around.
Exactly.
Yeah. I should say, just to give an idea of the big picture, there's like two directions. One is to be able to create differentiable functions in a more, how do you say, with more freedom. So that's what this net function would be. And you can put whatever you want inside. And the other one is to have alternative training procedures, training loop, so to speak. Because right now it's very simple. It's you have something that is differentiable and you have a loss function and you minimize this loss.
Yep.
But for problems such as you know, generative adversarial network or in reinforcement learning, it's a different paradigm. It's not just minimizing a loss function and having a differentiable function.
So describe how you would talk about what that framework is.
So, I mean, the solution is not entirely clear. I mean, okay, just to give an idea of the problems, like with the generative adversarial network, you have two networks.
Right.
So, okay, so you have one that generates, one that classifies. And basically, the one that classifies, it will be just a simple training loop, you know, with the data to be classified. And for the generative, it will be to put the classifier inside the loss function of the generator. And so you need to alternate. You need to train a bit the generator, train a bit the classifier, then train a bit the generator, and so on. And so this is not a natural fit for net train where you have just a loss function that you want to minimize.
Right. So roughly, what would we have there? So basically, what it is it's a multi-network. It's something where the loss function depends on the training of another network.
It's not really a loss function, but kind of. I mean, there's a training. Each of them have independent loss function, and the result is how. I mean, it will depend on how much you train the first network, and then you train the second network, and depending on this training procedure, it will give a different result.
No, I understand. Okay, so what do you imagine that the function that represents these adversarial network training things will look like? I mean, roughly.
Maybe Sebastian can talk about it. There was an idea. I mean, we had an idea of incorporating that into NetTrain.
Yeah, so I can. So we actually had a very long design sort of discussion during the conference about this, and we think we've actually come up with something quite nice.
Oh yeah, what is it?
So just so you know, there's two different approaches you can take to this problem. So one is that you can drop down to like what PyTorch does or something like that. And in that case, you basically write differentiable functions, and it's up to the user to update the parameters. You have massive amounts of flexibility, but it is also...
Let's talk about what a differentiable function looks like.
So going low level. Yeah.
No, but I mean, let's talk about what a function looks like, what a differentiable function looks like. So let's say we have something like this, which has, a couple of parameters here, and we have parameters which are, we have two kinds of parameters. We have sort of the, input-output parameters, and we have the trainable internal parameters. Is that correct?
Yes. And there's also potentially other parameters inside the net, like intermediate.
Right. And there might be fixed internal parameters as well.
That's also true. Yeah.
But so in rough terms, we have, we'd have a function. I mean, it's a little bit unclear how this would work. I mean, so there's two kinds of things here. There's these ones which are potentially, I mean, I don't know what order these are given, but let's say these are the training parameters, and these are the, ultimately it's going to return, okay, at any given moment.
So what you usually do is you say one of them is like, let's say, is a convolution layer. So X is equal to convolution layer. So that's now a stateful object that you can use in multiple parts of the network.
Okay.
But it could also be potentially a tensor, for example, like net array.
Yeah, it could be a bunch of weights.
Exactly.
But I'm trying to understand here the way we think about it, because ultimately what we've got, and this relates to how our layers work as well, because our layers are, in a sense, representations of differentiable functions where their differentiability is not declared, so to speak. Am I making sense? So in other words, in a situation like this, the fact is it's got a bunch of differentiable parameters in it, right?
And parameters. And you can get the derivative of the parameters with respect to, the input or things like that.
Right.
The output, actually.
Well, okay, so the thing I'm trying to understand, the directions to go in, one is, I mean, right now, this is a bunch of function compositions, basically, which have implicit differentiable parameters in them, if I'm understanding correctly.
That's correct. Well, exactly. So each layer is differentiable, and then the whole thing is differentiable.
Quite. But in a sense, if we had a way, I'm trying to understand let's say we have a function here. Let's say we have function x, x squared plus y. Okay. Now we could imagine differentiating that. What happens even if we try and differentiate that with respect to y? How bizarrely confused, if I'm not mistaken. What happened there? I'm just totally confused by what that did.
Well,
I mean, it's treating it as a symbolic expression, x squared plus y, and then.
Oh, it's a partial derivative. That's right. It's a partial derivative.
Exactly.
And so it takes, okay. So just to be, wonder what that will do. The heck is that doing? Oh, that's differentiating dx by dy, because it doesn't know that x is supposed to be a parameter independent of, and we could tell it that by giving it, by saying that x is a constant with respect to that differentiation.
Exactly, yeah.
Which I'm sure there's even an option to do here. Oh, I see. But now if it's a constant, then when you differentiate it, it will give, wow, that's really confusing. Okay. Okay, so explain to me what this is supposed to do. So in a sense, there should be a net derivative here.
Yes. So basically, yeah, I guess the one difference here is that obviously you can't symbolically differentiate this necessarily. Mm-hmm. So it would return some sort of differential function that if you give it some input, it will return the derivative. So at the moment, obviously, it uses this net port gradient.
Sure, but I mean, we have this idea. I mean, like, for example, if I say, you know, the zeta function prime at 0.2.3, right? Mm-hmm. That's exactly. You know, that is a thing which is the derivative is evaluable, but we couldn't get that by saying, you know, d, if we say d zeta comma x.
Yeah, it should return some.
It'll exactly just return some random thing like that, which when we substitute x goes to 2.3, we get the actual result. Yeah. So, I mean, the point that I'm making is, I think, particularly when you're starting to talk about things where we have named variables representing essentially the threading of these layers that we're doing here, and with NetGraph, is a threading where we are, you know, it's like data flow of some kind, right? As opposed to something where there are variables which are defining the causal network of the program, if I'm making sense. So what we're doing here, what we're doing is something that we've not done. We considered doing this a few years ago for functions in general. That is, I can say f of g of h of x, right? But in principle, I could define, just like we do with NetGraph, we could define ports for functions, and we could say, here's the graph that represents how data should flow between these functions. Am I making sense?
That makes sense, yeah.
Okay, so we decided, what was it, 3-4 years ago, something like that, maybe more, to not implement that for general functions. We had a design, but we decided not to implement it. Do you remember that?
I do not remember.
Primarily Tali and myself who worked on this.
I see.
Right? So, but the point is that that approach is a sort of interpolation between the kind of thing, because right now what we're doing with layers is very convenient for layers, but it does not relate to other kinds of things we do. And if you, you know, as soon as we're implementing arbitrary function layers and so on, and wanting to put in other kinds of things, we're going to have to address this issue. And I think we're going to have to bring closer what we have with layers to what we have with other kinds of functionality. And in terms of what to do with, so, okay, that's my point of view. And I think I'm simply not convinced that we're ready to de-experimentalize these things. And what is the proposal for what to change in version 12?
So the proposal is, one of them is, first of all, what type it returns. So at the moment, it's returning a list of numbers, but we want to have support for numeric array. That the default is that it returns a numeric array of type float32. And then if you say working precision goes to something else, then it will return that type.
What will return that type? The generic layer?
Exactly.
Wow.
Because it requires some type to return, and it's highly inefficient if you have to convert backwards and forwards between different things.
Okay, but I mean, this is then, look, you're making something lower and lower level here. So look, the things that seem to me the issues right now, one is correspondence with the other type systems, which you have not resolved, right? Do you agree that that's an issue?
It is, and then particularly for specifying the type. So for certain things, like this is pretty simple, right? The input, you can just say it's some dimension. Right. But for the more complicated things, like some of the layers, they have restricted integer types, for example. Then we have
another case is correspondence with data flow for general functions. That is the notion of, relationship between a graph, graphs and function evaluation, which we have in the case of neural nets, but we don't have it in the case of graphs. Am I making sense?
Okay, so just explain the graph case.
Okay, so in a neural net, right, if we say net graph, what we have in net graph, let's look at documentation, maybe it'll have a nice minimal example. There's a good minimal example. Well, here, what you're doing is, where's an example? Let's see. Do we have a more real example here?
Sure, the scope should have some more complicated things. There you go.
Okay, here we go. Beautiful. It was magnificent. Okay, so this kind of structure could perfectly well have arbitrary functions. That is, it could be the case that here's a function, f, that returns two results, okay, here, one of which is fed to a function g. G returns two results. One is fed to h, like this. And these things could be f, g, h, whatever. Now, a thing that we have not done, and this has shown up in the quantum computing case as well, is our functions don't have a good kind of canonical way to return multiple results.
I see.
You know what I'm saying? Which is what's happening here.
Well, we return, so our concept obviously is return associations with the port names.
No, I understand. But that's a perfectly good general pattern that can be used for quantum computing or can be used for other things as well. And in general, one could imagine, a style of programming in which the returns from functions are fed to other functions. We have a very good version of that, which is function composition, right? But yes. What we don't have is something like this. If you wanted to do this, if you wanted to write this where these are general functions, f, g, h, etc., there is no good way to write this right now.
Oh, I see. Sure.
Right? Now, on the other hand, this thing here could be written in terms of variables.
Correct. Exactly.
Right? So we've got three different versions of how that computation can be represented. One in terms of variables, one in terms of, these kind of graphs, and I suppose a third in terms of the actual net graph thing that's been implemented so far. Okay? Yep. And my claim is that has to be unified, just as what's happening in the quantum case has to be unified with this. Do you know what's been done in the quantum case?
Not much, no.
So it's worth looking at because it has the same issue. It typically has, end-to-end functions because it has to be, unitary transformations, right?
I see. Okay, I'll have a look at the quantum case.
Right. So look, my point of view is we need some, it's a very interesting design problem of merging. So, I mean, we got, okay, the type issue, we've got the issue of how we represent this kind of data flow thing. And then the other thing we've got to do is this kind of sort of, I don't know what you call it, the hyperfunction of net train, right, is one way to, is one form of, okay, so there's an analogy, right? We've got things like netfold and so on, which are some kind of higher order functions operating on networks.
Sure.
Okay, net train is even a higher order. It's some kind of hyperfunction that operates not on the structure of a network, but on kind of the way the network is used. Does that make any sense? I mean, it's just like in functional programming, right? We might have, I mean, in functional programming, we might say, okay, we've got nest. That's a way of using, what am I trying to say? You get what I'm saying? I mean, net train is a version of what one does given a network. It is a particular way of taking that network and doing, okay, it's a way of using a network. And what you're telling me,
efficient way of changing the weights of the network.
What's that?
So it's the only efficient way of changing the weights of the network to something meaningful.
Well, it is a way of taking, so the way to think about it, probably, I mean, again, we don't really have a concept with a function, like a pure function. The notion that we are going to incrementally monkey around with the inside of that function is not a notion that we particularly have. Right? There's a case where we're doing that, but that's not something that's come up in other cases.
I mean, I guess the sort of n-minimize type things are somewhat similar. Like you have some parameters.
Similar, yeah. Actually, a good example would be FindFit.
Okay,
right? FindFit is a good case where I mean, that's a pattern. So FindFit is a pattern where we have a generalized function, right? And where what we're trying to do is to fill in, well, okay, yeah, probably. What's the other thing that we have?
We'll find minimum. Yeah, it'd be similar.
Right. I mean, what this is doing then, we could have represented this differently, and we could represent this with. I mean, so let's look at what it would take to have FindFit be. What would FindFit? What would the net train analog of FindFit be? Do you understand what I'm saying? Right. So what that's saying is, the net train analog takes this function ax log b plus cx, right?
Mm-hmm.
And in your net train world, a, b, and c are not named parameters. They're things that would be, what you would have is something like, I mean, let's say fungible function, okay? Bad name, okay? ABC of a function. And again, this is not well named particularly, but let's just go through it to see what the basic idea is.
Yeah, so you declare
exactly
which are the parameters in the function. Yeah.
Right. And then what would happen is, then what FindFit would do, if FindFit is being told, this is the training data, whatever it is, I mean, it's probably going to have to give so it's being given training data which says this, x equals 1 goes to 2, x equals 2 goes to 3, 3 goes to 5, et cetera, et cetera, et cetera, et cetera, et cetera. Right? And that would be the kind of, that would be the pattern. I mean, this idea of a function that has parameters that can be modified is a perfectly good general idea, relevant for things like FindFit.
Yeah, that's what net function. That was a goal of.
I mean, that's kind of the net function idea, right? But
exactly.
My point is that we need to try to unify that with other things we're doing. So, for instance, here, the it hasn't been convenient to represent. See, this could be perfectly well convenient. I mean, having a function that represents the fit here, it's a perfectly reasonable thing to do, rather than having explicit parameters. We have to get values of parameters and so on. Depends what you're doing. In this case, I mean, in a sense, interpolating function is a little bit like this, except that interpolating function is not incrementally updatable. Am I making sense? I really think this conversation needs tally, but you get more or less where I'm going.
No, I understand exactly where you're going. Yeah, it's a general concept, and yeah, it might make sense to make this to build this into language better.
Right, that's my point. So I mean, I think that the tendrils here are, we've got this kind of whatever fungible function, whatever you call it, right? It's almost like a parameterized function, which is another concept that we actually have.
Yeah.
Don't we? Parametric function,
yeah.
Right? So what is a parametric function and how does it relate? So that's a little different, right? But how does it relate? See here? So this is a function that has
needs
been
a parameter. Yeah.
What's that? It needs a parameter, but what this parametric function is that parametric function arguably is the fungible function, which is then going to be fed the explicit values ABC, and then going to return a function that is the actual sort of feed forward function, if that makes sense.
Yeah.
Right, because this function still has loose parameters hanging out, just like this function still has loose parameters hanging out. Okay, look, okay, so look, this is what I think we need to be thinking about. So this is one direction, is, you know, whatever we're calling it, fungible functions. And so we've got parametric functions. By the way, is somebody here taking notes about these issues? I mean, this really kind of derailed from what, this isn't really, as I expected, this is not quite a, oh, we're just going to make this function non-experimental. And I don't think we have, who is project managing neural network stuff these days?
I think it's Shushma.
Okay.
But
Well,
I'm making notes and I can relate them to Shushma.
Please do.
Yeah, also making notes as well.
Okay, but so anyway, one direction, we got weird background noise here, which I'm suspecting is Sebastian's fault. You know, one direction is doing better with this fungible functions concept. Okay. The other direction is this data flow for functions. Okay, knitting functions together. Okay. And actually, let me write that down separately, because this is really, I'm going to put this, let's actually save this someplace in my system.
Yeah, can you just email this to me as well?
Yeah, I will.
Thanks.
Actually, if I look in my neural net framework, I'm sure we have the old notes from 4 years ago about, although, you know, we've got a huge amount of new experience since then.
Yeah, that's true.
Right, which is what we kind of expected. We kind of expected we're going to build something which is specific to the way neural nets work right now. Okay, so then here we've got this notion. Okay, so let's look here. So that okay, so then we've got this, what we're calling fungible or parameterized, fungible, differentiable, whatever you want to call it. It may not be differentiable, etc. functions. Okay, actually, a better term here will be meta functions. So these are functions that are things like nettrain. Okay, that are functions that operate on these other functions.
Sure.
That do a pattern. So, for example, FindFit would probably be an example of such a thing if it was set up to operate on this sort of fungible function. Okay, nettrain is the same way. Now, what you're telling me is that something like, you know, GANs is yet a different pattern.
Well, we think we can fit it into nettrain with a slight modification from nettrain.
I'm skeptical. So go ahead.
Okay.
Go on.
Sure. So yeah. So the idea is that nettrain can have, so the current design is that nettrain, the first argument is the net, that you can have a list of nets.
Okay. Well, that's interesting. But then, is it a fixed training network here?
And then you need to declare kind of the training procedure for this net.
Okay, well, so then tell me about that meta function, which is the training procedure.
Okay, I mean, so basically there's already a pattern for this, which is generator functions. So that can either be a piece of data, or it can be
I'm sorry, what are generator functions? What?
So yeah, so the second argument can either be some actual data, or it can be a function that if you supply.
I see, like an active classification, for example. Active classification has this generator function feature. Is that correct?
I think so. Etienne will know better.
Right. So, okay. So a generator function, but it's got to know what, it's still pretty funky because it's got to know kind of where the arguments flow in these networks.
So the thing with the generator function is that if you give the generator access to both networks, so the current state of both networks, then they can use, so basically the idea of GANs, for example, is that one of the networks, it generates lots of fakes. And so it needs, the other network, the discriminator that is trying to see whether it's fake or not, it needs to have access to the other network, the one that generates things, to generate some training data for it. So there's some real examples plus some things that you've hallucinated from that.
I was entertained to see some discussion recently about cuttlefish as GANs. Cuttlefish have this weird camouflage, right? But, so who knows? We'll
they say that the evolution is exactly similar to the training procedure of GANs, because the predators are the discriminators.
Exactly.
Yes. Right.
And the generators are the cuttlefish. Yeah.
Right. So okay.
Exactly.
But so explain to me then, what does this actually look like for a GANs setup?
So the GAN will look like, so there'll be two nets.
Yep.
And then there'll be two generators. So there'll be a list now of either data or generators.
Okay. What do the generators do?
Sure. So the generators are pure functions that you give them an association, and that association contains a bunch of information. So things like what the batch size is that NetTrain is using, and then also things like the current state of both networks. That comes with that association.
Okay, but so if we look at active classification, for example, it is being given, its function is being given certain things, right?
Yeah. So
what is it being given?
Yeah, the second argument, the first argument is oracle function. And the second is the space of input of this function.
Right. Okay, so in that case, what's happening here is this sampler or the region defined here is giving the set of possible inputs that F can get. All right, listen, let's not continue this right now. We've got other things we've got to do in this meeting. But I think, this is the challenge, right? Is to merge these ideas and to come up. I think we're not far away from being able to do this, actually. And I think if, we kind of needed Tally for this, it's kind of annoying that didn't logistically work out today. But why don't we come back and look at this again when Tally will actually show up?
Sure.
Okay. And I think we might want, in this discussion, it might be useful to have possibly Roger and conceivably Jose. But again, I'm also very keen to understand. So this thing about, we do need Jose actually, because this relates to the quantum framework stuff. Right? Because I really want to understand this question about, you have a graph, the graph has nodes, the nodes correspond to functions. How do we evaluate that graph? Because that's what effectively we're doing in the case of a net graph. Make sense?
Mm-hmm. Yeah, makes sense.
It's everywhere. Yeah, programs as graph is
exactly.
It's a thing
everywhere.
Right.
And that would be the same for probabilistic programming thing.
I agree. Right. Another thing that has to be merged with this.
Yeah.
Right. Yeah. Because that's what that is. By the way, the reason programs as graphs is obviously equivalent to programs with variables.
Oh.
What's that?
They're less powerful, but more interpretable. And
well, no, look, with graphs, the problem with a graph is you have to label. The only way we know to represent graphs, you can say, here's a graph, right, as an abstract thing. But ultimately, the only way we know how to symbolicize graphs is by labeling nodes. Even if we label the nodes with integers or something, we're still labeling nodes. The graph could have an existence on its own, but the only way, it's a little bit similar to what happens with lambda functions. The function has an existence on its own with arguments and so on, but the only way we know how to really engage with it is to label those arguments. Did that make sense?
Yeah. But also the issue that a graph is kind of fixed.
So as soon as we're doing that labeling, we're sort of equivalent to having variables. But we feel better about having a graph with 1,000 nodes that are, numbered from 1 to 1,000 than we do, having variables x1, x2 through 1,000 with names like that. Or am I confusing something? Did that make sense?
It makes sense, but like the second problem is that yeah. Do you hear me? Do you hear me?
I hear you.
Did we lose you guys?
Oh, I think Stephen doesn't hear any of us.
Hello, anybody there?
We're here. Do you hear us?
Not good.
Hear us.
Oh dear.
Okay, let me see whether I can reset something here because I can't hear you.
It's funny, we also heard, I don't know if you heard also, there was a little bit of breaking.
Yeah, I also heard that.
Maybe this can be a sign.
That's really strange.
Investigation.
Okay, so what was your response to
Do you hear us now?
No, I can hear you fine.
Okay,
yes.
Cool. I was saying, that makes sense. Another important thing is that a graph is kind of a static structure. You cannot have conditionals like, if statements and loops and this sort of thing. So that's all the limitation, which is actually for neural network, the main limitation for NLP and things like that, where you have things of various length, when you want to generate trees, for example, that are not necessarily balanced.
Yeah, okay, fair point. So I mean, it's like you're saying the structure of the program, the data flow in the program is not modifiable.
Yeah, but
it's all been.
Yeah, exactly. So basically, exactly. So the program at runtime, it's fixed with a graph. But yeah, and for neural networks, like the recent sort of things have used runtime, it changes the actual graph.
Right, but so for things like differentiable programs and so on, you can have programs whose execution trace changes depending on the data.
Precisely. And that's something we want to support.
Which is a little different. I mean, there's a final thing, which is the actual program changes based on data. See, for example, in genetic programming, for example, the concept was the program changes somehow. In reality, those things have a bad habit of degenerating into just having a few parameters, and I
mean, that's what the NetTrain is. Huh?
What's that?
That's the goal of NetTrain, to change the program with the data.
Well, I understand that, but it isn't real because all it is really changing is these pre-set up parameters. See what I'm saying? I mean, you could, in principle, look in the space of all possible symbolic expressions that represent programs, and you could go, as we have done, on a great big search in that space.
But this is not exactly true, because if you have dynamic execution, then there's an if statement, and the weights change a bit, and suddenly the if statement gets triggered now, and that if statement has a completely new, code path. So the program is actually.
But that is not. But you had to build that in. In other words, in some sense, the trilobite already had to encode, humanity, so to speak, if I'm making sense, right? Within the trilobite, somehow there had to be a nascent pathway that made, human-like eyes or something, right? Which is, of course, not the way it really happened.
Yeah, we could also imagine that net train as instead of having a fixed network or even a net function, something that capture a broader family of networks.
Exactly. But I mean, but look, the issue is it possible to kind of go exploring in the space of all possible functions, or are the functions pre-parameterized? Right? And what we're saying is there's different levels of pre-parameterization. One is that the thing has a fixed graph, fixed execution trace graph, and fixed data flow graph. And that's the level. So
I completely agree. It's very important. I mean, I think that would be an extension of this fungible function. Like we have this function that has 3 parameters, right? And then we could have one that doesn't have 3 parameters, but arbitrary number of parameters. And a sort of, I mean, we include the definition of the space of these parameters.
Well, that's one way to think about it. I mean, look, the main issue is code equals data is actually true for a symbolic language like ours, and it is in principle possible to imagine learning in that symbolic space. Not what's done right now, right? Not what we know how to do. We don't understand differentiability in a space of functions like that. We understand differentiability in a space of parameterized functions, but not in a space in the sort of arbitrary symbolic space of functions. Look,
so,
I mean,
differentiability might be just too restrictive for that. So the sort of way that people do this, for example, like looking for new topologies and networks, is using reinforcement learning, which has no restrictions for differentiability.
Yes, I understand.
Yeah.
So explain to me another thing with respect to that. So obviously in the world of cellular automata, for example, we have the feature that we are just looking at an arbitrary space of functions, right? There's no sense in which, I mean, in that particular case, well, look, there are 2 levels of function we could look at. One is take arbitrary Wolfram language expressions. Another more modest thing is take arbitrary cellular automata, okay, or arbitrary Boolean functions. Now, the Boolean functions have a representation that is, in terms of ands and ors and so on, that we will be hard pressed to kind of explore that space by just, tweaking ands and ors. It so happens that space has a more sort of explicit representation that we can in principle explore. But actually, first question, with respect to reinforcement learning and its relationship to things like learning cellular automata, which don't have, is there anything interesting that one can, I mean, you understand what I'm saying there?
Sure, I understand. I'm actually not sure. I think this would be an interesting experiment. I don't know. I've never seen any literature about it, but
all right, something for the summer school. You're coming to the summer school, right, this year?
Yes.
Okay, we'll add that. I'm going to add that to my list for somebody to look at. Hold on, let me just remember to do that. Hold on 1 second here. Where are we? All right, here we go. A big long list of weird things. Let's see, reinforcement learning. Okay, but in any case, let's, by the way, we have a couple of interesting comments on the live stream here. One comment from Michael Hale is, isn't data flow graph programming like what happens in System Modeler? That is true. Good point. I mean, that's yet another. So in System Modeler, the way this is done is we're representing, we have named variables. We have graphs, but we are labeling the graphs using named variables. That's another really good point of something which should be unified here. Do you know what I'm talking about, Sebastian?
I know vaguely about this. I haven't used System Modeler much at all.
Well, I mean, so if we look at an example here, let's see what we can do here. This is kind of this function is crazy, which is why it's experimental still. It will be much cleaner in future. But let's just take an example here of how let's come on, wake up. Boy, how can it take so long? Well, I guess it's loading in all kinds of crazy stuff. Okay, one should use the cloud where it's pre-provisioned, at least when, okay, what should we pick? Let's pick physics. We're supposed to know a little bit about that. Let's try bouncing balls.
This, by the way, might have some nice reinforcement learning environments as well.
That is a good point. What is
so there's something we wanted to look in the summer school.
Yeah, that's a good idea. It's a good idea. In fact, that needs to be added to the list as well. Hook up system modeler as a reinforcement, as a
reinforcement learning environment.
Actually, what's interesting about that is being able to find the analog of interpolating functions, because what system modeler does is it finds given some particular area. I don't know what these examples. Let's try introductory examples here. What are we looking at? Component based. All right, whatever this is, block circuit here. Yeah, so I mean, a circuit diagram is a quintessential example of this type of thing. Let's see, how do we actually get this? Copy the model. But now, so what is the analog of the graph for this? How do we get something like the graph? Well, answer, we have a bunch of equations that represent that graph that happen to be nasty differential equations. But I wonder where the, interesting. Yeah, good point. I mean, what is the analog of this? This is not thought about. Okay, so what happens in a case like this is this graph defines a bunch of equations which are then solved for the state of the system, as opposed to there being a feed-forward mode in which, see, the analog of the feed-forward mode, boy, it's an interesting analogy. Anyway, okay, I don't think we have to, let's not go down this particular direction right now. There's another question here on live stream. Somebody was disappointed that Bayesian max, Bayesian min were never able to optimize complicated choices in neural net design. Are we working on something like ENASE, which I don't know what it is? Etienne, can you comment on that?
I don't know what ENASE is.
Okay. Well, but in any case, the question is being able to use Bayesian minimize, etc., to change parameters of neural nets.
Yeah.
I mean, what is the story with that, and how does it relate to? I mean, that's again relates to this meta function question, because this is, that's again one of these patterns for how you can change parameters of things.
It's like an outer loop.
Right. Well, okay. So they're otherwise known as outer loops. Right. So the question is, what outer loops? How do we think about this notion of outer loops? In, I mean, this is kind of the slow. What am I trying to say? I mean, this is a a very minimalist outer loop would be something like a select among cellular automata for, among some list of cellular automata for ones that have some particular property. That would be our minimal kind of exhaustive search way of doing something, if I'm making sense. And these things here are attempts to have more, incremental outer loops. So there's, exhaustive search type outer loops, or various kinds of evolutionary outer loops. Okay, this thing is called efficient neural architecture search via parameter sharing. And we're being given a reference for this, which we should look at. Have you heard of this, Etienne?
Let me look at it. Efficient, because I don't have a link.
Oh, here, I'll send you. There you go. Okay, someone else was commenting earlier. One challenge you may need to solve to unify everything is how to symbolically compute gradients of functions networks using vector matrix operations. I mean, the wrong group of people to talk about that. I mean, we're.
I can actually answer this quickly. So
okay,
it's actually there's two different types, or there's three different types of differentiation in the literature. So the symbolic differentiation, and basically you have, for every variable that you've got, you're going to have one expression for that. So if you have 1,000 parameters in the network, you're going to have like 1,000 derivative expressions. But automatic differentiation is quite different from that.
Right.
And it's algorithmically much more efficient.
Right. And it's what we're implicitly doing all over the place.
Exactly.
But we have not made it explicit for a broader class of functions, which is an interesting thing to think about doing.
Yeah, it's a very general technique. So,
right.
With lots of application areas, not just neural networks.
Right. Well, we've implicitly used it in all sorts of places. I'm sure we implicitly use it in System Modeler. We just haven't exposed it because we don't have a good packaging for it at top level. All right, listen, I think we should wrap this particular segment here. I think the conclusion is we need to talk about these more general issues, and let's set up a discussion for that.
Okay, cool.
Okay, and then I will send on this notebook to folks who are relevant to that. All right, we're going to turn to a complete. Oh, wait a minute. What's this? The net encoder, net decoder. Well, we're not going to do these if we're not doing the layers. We're not going to do that for encoders and decoders.
Sure.
What on earth is this? Why is image 3D? Image 3D is not. Oh, that's a net decoder, right?
Exactly. Yeah.
Yeah, but I mean these things are. It's unclear to me. I mean, is there any general discussion that we need to have about these things? These are things where we're basically just taking, it's the, I don't know, it's our modern analog of Gödel numbering, in some sense, right? Take anything and just turn it into a bunch of numbers for a neural net. And
yeah, for net encoder, yes.
And net, yeah, okay. Well, net decoder is the inverse of that.
Exactly. So it's finding a numeric representation of some other type.
Yeah, there's never a new idea under the sun. That's the same as Gödel numbering in some sense, except this is a lot more practical. So a question about this is how general. So I mean, the issue is it matters a lot what the encoding is, whether the neural net is actually going to be able to learn anything, and so on. And what class of types are we able to do this for, and what is the meta way of thinking about what the encoding ends up being for different types? Did that question make any sense?
Yeah, I think that's a reasonable question. So I think for certain types, like images, it's pretty clear there's a numeric tensor representation, and neural networks want to act on numeric tensors. So it's more interesting for audio, the same situation.
Well, so things that have space and time as sort of features of them have a very clear notion of how they can map into something where sort of space and time are preserved.
Sure.
It's less clear, for example, when you have a tree-structured grammar, for example, it's a little less clear. There is an ultimate temporal sequence, but it's less clear that that's the important thing.
Sure. So there's a discussion at the moment for like how we should deal with graphs, for example.
Yeah, good question. So I saw that. Have you figured that out? Have you got a reasonable representation there?
I have not had time yet, but yes,
what have people tried to do there? I mean, it seems to me it depends a lot what the graph is going to be used for and what it represents.
Sure. So, for example, one thing you might want to do is predict, for example, like a citation network. So you have a network of citations, and then one node might be missing. And you want to say, given the surrounding nodes, predict what the missing node will be, for example.
Yeah, so we did that. Remember we had that project at the summer school a year or two ago of our See Also citation network for the for our documentation?
I do remember vaguely this project, but I can't remember the details.
Yeah, I also don't remember the details of how it was done. But that's it. So let's take that as an example of where you want to use a graph as the thing that you're working on. Humph.
There's that, yeah. So there's that, and there's also, for example, you want to take in a graph and then predict something about it. Like
well, so I mean, one naive thing to do is just take the adjacency matrix and just say, I mean, the problem is that in an adjacency matrix, there's either an edge or there isn't. And it doesn't tend to be the case that it's a sort of differentiable thing where there's 0.1 of an edge or 0.95 of an edge.
Sure. That's fine. So you can take
I guess that's right. You can threshold it perfectly well, just as you do for lots of other neural net operations.
Exactly. And the special convolution types that act on these adjacency matrices that people have developed.
Okay, so adjacency matrices are one approach. And presumably the sparse matrix is that there's a sparse representation of the graph. Can one expect to operate directly on the sparse representation of the graph?
So things like MXNet support sparse operations for purposes like this. Because
no, but I understand that. But I mean, what is the encoding? You know, when you make an incremental change to the sparse representation of a graph, what do you end up with? I mean, when you make an incremental change to the adjacency matrix, it's pretty clear what you end up with.
Sure, that's a good question. I'm actually not sure.
Well, you think about it. I mean, you know, there are basically two things you can do. You could spawn additional elements, non-zero elements, or you can change the values.
Sure. But I guess the tricky part is that how do you prevent just all the elements becoming just spawn the whole thing? Like you need some thresholding or and that might be messy to keep it differentiable nicely.
Right. And it's also not clear, you know, what does it mean to spawn nearby? I mean, you know, another way to think about this actually would be, okay, so here's another way to think about it maybe. You know, the question is, what changes do you think you want to make to the graph as you're trying to modify the graph, right? So how do you make incremental changes to a graph? So the answer is that's not particularly easy. You know, there's graph rewriting type stuff which one can do, which is pretty hard to define. But that's, I mean, the most obvious way to make an incremental change to a graph is to rewrite some local subgraph as something else. But then the question is, if you want that to be done by a neural net, how do you, boy, that's complicated. Because, you know, as you change the number of nodes, you're completely changing any operation that changes the number of nodes. The adjacency matrix representation is not going to help you very much.
Sure.
Okay, so that's an example of a difficult case.
The easier cases are things like you want to classify some graph as being, let's say a chemical that is reactive or not reactive, as an example of this.
Well, I mean, in chemicals, there are smile strings and things like that, which I would suspect you can treat probably very much like sort of pieces of, you know, like linguistic sequences, without having, you know, one-dimensional linguistic sequences, maybe with some tree structure, without having to address the whole graph theoretic, you know, setup.
Yeah, so there's going to be all kinds of approximations of the graph that are amenable to some.
But the question that I have here is, we've got all these random net encoders. My question is, what's the general way to think about that? You know, the general way is you've got some data structure, you're grinding it up into numbers. Yeah. All right. Well, look, let's move on, because we're not going to resolve these things right now. All right. Well, I think that's it for you, Sebastian. And I think actually, hold on. We are now on to, oh boy.
Yep.
This is another complicated area here. Okay. Do we really think, and I'm afraid this is not completely unrelated, do we really think text element is ready for prime time?
Well, I'm not sure, as I wrote. But can we imagine a different design? I mean,
Well, yes, we've got several related things, right? So this is what's relevant for abstract syntax trees, right? Which is, I mean, this is effectively an abstract syntax tree for human language that we're dealing with here.
Mm-hmm.
You know, I don't think, the reason I'm not happy with these yet is we haven't had enough experience actually using the results of you know, text structure, for example.
It's true. It's true. So we had a lot of feedback of people that just didn't know that they can use a structure. We also had feedback of people using the structure and being pretty happy with it.
I know. I've seen that too. Which is good. I mean, always what one wants to see. But, you know, the question is it the best way it can be done? I mean, I think it's a reasonable way to do it. I think it's not, you know, I think it is usable. You know, the other case that we looked at is, okay, so we also had this long-running project to do the analog of text structure for code, right? C code, for example. And I think that there are at least preliminary results from that, right? Where you're annotating a piece of C code, or for that matter, a piece of Wolfram language code, using this kind of abstract syntax tree type notation. That makes sense, right? So in other words, you're annotating a piece of C code, you're saying, this is an identifier, this is a declaration, this is a whatever it is. This whole thing is a, gosh, I'm forgetting my C syntax names, but you know, is a clause or something, whatever. That makes sense?
Mm-hmm.
And so there's an analog of this for that, which I think we kind of need to look at. Now, with respect to text structure, why on earth do we not want to de-experimentalize word translation? That seems to be a case that is rather straightforward. What is the problem with that?
It's not my function. I don't know.
Well, the fact that it's not your function doesn't mean that it, I mean.
No, so, I know, but I don't know who.
Well, it's Alan's function, I think. So Raj, what was the story with word translation?
Right. Alan didn't get back to me yet about word translation. So I just left it as is for now.
Okay, so I think that one is actually one that can be de-experimentalized. I'm not confident about text structure because I feel like text structure depends on the text element business, which is pretty good, but I'm not completely confident about it. Like, for example, one of the issues here, I mean, it really is pretty good what's happening here. What has happened, by the way, to our neural net version, full neural net version of text structure?
Of text cases.
What about text structure? I thought we were also going to do a parser that way.
No, we never had.
Really?
No, we do that.
I thought we were discussing that, a multilingual parser that way.
No, I think there's been some confusion about. There was what was it about part of speech like
a part of speech tagger.
Yeah, it's more about part of speech, and also about a norm, international norm to, you know, because all language have different things.
Like, but the add position business to represent, you know, prepositions and postpositions and so on.
Yeah, but we never had the idea of ourself training like a multilingual part of speech or text structure type thing.
Okay. But I think we also were discussing the possibility of, for example, generalizing, you know, this business about replacing the preposition tag with an add position tag, which is utterly obscure to anybody who knows, you know, who's used to English. It's utterly obscure.
Mm-hmm.
And you know, what would be, again, wrong group of people here, but what on earth is our approach to dealing with that? Because if text structure returns specifically preposition, I mean, I think it would end up having to have some option in this form thing. Yeah, that's the right way to do it. This form option should be able to say whether it is internationalized or not. Am I making sense?
Mm-hmm.
Anybody here know a language that has postpositions? No. Okay, fair enough. We don't have enough people in the meeting. Eventually, we'd have enough people that somebody would know a language with postpositions. Okay, why on earth are we not de-experimentalizing snippet? Raj, is that another one where people didn't get back to you? Wait a second.
No, there is a comment there.
Nicholas, this is us.
Okay.
So I think what we were saying is that we weren't sure if the content object, search result object. So there is a use case for that in the documentation, but we don't know if that part is going to stay the same. The other, 5
yeah,
uses.
that's a horrifying case, right? So that's giving you a snippet that is contextualized within a content object, saying this is the sentence where the word, cuttlefish or something was mentioned.
Yes.
And do you believe that? Yeah, okay. So is this working right now? Is this how you do those snippets in the search results?
Yes. Yes.
And what aspect of a search result object is the thing that is used to snippify the content object?
The query.
So it redoes the query in some sense on the content object.
Because you need the original query.
I see. So in other words, if I took a content object, so if I had done a search for cuttlefish, and then I insert a completely new content object in the snippet that happens to contain or not, what happens if it doesn't contain cuttlefish?
Well, this is unrelated to the search itself. So,
but they don't have to be in this presentation.
The contextual snippet will be calculated at this time.
Okay, let me go through this again. Let's imagine that the search result object, which contains the original search cuttlefish, okay, doesn't,
yes,
that's fine. So we put it in there as a second argument of snippet, okay? But the first argument of snippet is something that had nothing to do with the search result object. It's a completely other piece of text about oak trees, okay?
Yeah.
What happens?
If there is no cuttlefish in that content object, then there will be no snippet.
Okay. So in what sense, why are we even bothering to put a search result object here if all that we're using from the search result object is its search terms? Why isn't it just a list of search terms? Why don't we have a form where what we're effectively doing is to say, for the snippet, why don't we just say snippet? I mean, that seems like a perfectly reasonable thing to do. Snippet, a piece of text, comma, search term.
Yes, but Lucene takes the whole query that can be a complex thing in account.
Fine.
Not just search terms. So a way of
fine.
passing...
But that could be, that we could equally well say a query here, but we don't have to have the results. You're saying that the thing is going to research, so to speak, this text. Is that right? Because what's happening here, this is a specific use case where it's like a search engine where it has already decided the page you want out of the billion pages that were fed in, the page you want is this content object page. And now you're searching within that content object page to know where the relevant snippet is, right?
Yes, yes.
Okay, so let's walk through that again, because essentially the general case of that is you've got a piece of text and you're snippifying it by some query, right? Which is different from the case that this is the minimal case. Okay, so let's walk through this. So in the case of text search, we are used to the idea that we've given many files and we are saying which file contains our relevant, piece of text. There's a different thing we might do, which I don't know whether we have a way to do, which is give me the surroundings. I mean, it's more like text cases. Give me the surroundings of this word in this particular piece of text. Am I making sense?
Mm-hmm. Yeah.
Do we have another way to do that isn't snippet?
Not that I am aware of.
Right. So I think this is not right. I think that the correct version of this would be, and a syntax that we certainly can still support is something as simple as this. Right. Now,
yes,
the issue here.
Yes.
The issue here is that to get the full version of this, we're going to need a search term. And I mean, arguably, the correct form might be something like this, where we've got a search term and we've got a number of lines. See what I'm saying? Because what that would say is centered on that search term. I don't know whether that's the right way to represent it in the snippet, but that seems like a useful thing. Centered on the search term, show me a snippet of the text, some number of lines around that search term.
Well, it would be maybe like an option, like not for a specific term, right?
What?
How much text around the
no, but we've
size
already
of each
got
fragment.
That's what the second argument is doing in these other cases.
Oh yeah, yes, that.
Right. So what this is a good idea to have something where we can have a contextualized snippet, and maybe the default is, if the second argument is just a string, the default is, I don't know, whatever this default is, whatever the number of things is here. So this would be a much simpler way to do this, where we could, as a courtesy, so to speak, support feeding in a complete search result object, but the more minimal case would be to have a search term and a search term and a number of lines. Does this make sense? I think this is a good extension to snippet.
Yeah, probably yes.
Okay, well let's iterate that. I think this is de-experimentalizable for 12, but let's bring that back. If you can look at implementing that and the details of the design, then let's bring this back again. So that one is not. So Raj, that one is still in the running for de-experimentalization.
I'll mark it as such. And I just heard back from Alan. Stephen, he agrees that word translation can be de-experimentalized. So.
Okay, so I agree with that too. So let's just go ahead and do it.
And did you want to de-experimentalize text element and text structure or no?
No, I do not.
Okay.
At this point, I think we've still got some issues there. I think who is dealing with text structure?
Jerome.
Okay, so the first thing is this internationalization for add positions and so on, and the second is the correspondence with code structure. And actually, the third thing is the trees project and making sure that this dovetails correctly with the trees project. So, by the way, word translation, the only other case that we need to probably explicitly mention is the all case. We probably should mention that in the primary documentation here. That's something for Alan, Raj. Okay.
Okay. I must say it's not a priority for text structure. I mean, it won't be for Jerome.
No, I understand. That's fine.
Yeah.
I just want Jerome to think about it. I agree.
Yeah,
it's not a priority.
Priority is the next thing. Text case.
Well, I mean, text cases has been way too fragile so far.
Yeah.
But
so
with Jerome's work, it is not. We hope.
Yes, exactly. So right now it's not de-experimentalizable, but hopefully for 12 it will be.
Good.
There's been some great progress. I think now we have a good data set.
Do we like the design?
There has been some voice so that the output is an association,
Nicholas,
for
could you put
example.
yourself on mute? You are making a noise here.
There's still some. There have been some asking for a different output when you have several properties. When you put form arrow prop and you put a list of properties, and often
what is the output right now? Is it even defined what the output is right now?
Well, actually property or several form, like if you do, it's really when you mix things. So when you say, I want all the words and all the nouns, so you could put like in a list now, text cases, word, noun, and some people got a bit confused because.
Right, it's unclear. I mean, this is an outer product question for, if I say noun verb, right, it's kind of unclear what it should do.
And right now it's going to be flattened. So it's going to take.
I see. So it's going to be the alternatives of that.
Exactly. It's like an alternative. It's exactly like an alternative at the moment.
Why did the fox not make it as a noun?
I don't know. Can try text structure.
But text structure and text cases may not do the same thing.
It's true. There might be a faster thing for part of speech.
Well, there is. There's a part of speech. I mean, there's a specific part of speech tag thing. This is probably loading some giant setup. Why is this so slow? What is it doing? And if it is so slow, and Raj, it's an issue for you. If it's that slow, it needs a loading indicator.
Okay, I'll follow that up.
Okay. The fox is a noun. How come the fox got lost?
Yeah, we're actually going to switch for 12, I believe. I think Jerome was telling me that.
Switch to what?
To the same part of speech that doesn't text structure to use in text cases.
Wait a minute. Is text structure going to switch to the text cases case, or is text cases going to start?
Text cases switch to the text structure case.
Okay, well that's good because then the fox will not be lost.
Yeah, this was like a prior model we had that is pretty fast, but has some problems. Yeah, so that was the thing. So I think we need with Jerome another meeting to settle down this design. It's something that, by the way,
outfox somebody. I didn't know there was a verb form of fox. I know there's a verb form of outfox, but I didn't know there was a verb form of fox. Anyway, no matter. Go ahead, please.
Yeah, so I think we need a meeting. It's also something that Farzad brought as well when he was developer of text cases. This thing of having an association as output, and yeah, may have been, I don't know, changing my mind about that. But I think it's worth switching to a more, having association as an output when you have several form or several.
Yeah, I think it's interesting to consider association as output.
So we should think about it. See a bunch of real examples.
Yes, I mean this is analogous to other functions which have which have this outer product kind of character of having because the issue here is both the form and the properties.
Yeah,
and that's similar to what happens in entity value, right?
Yeah. So try to put a property, for example, noun verb. Then now you put arrow, and then let's put a list. Yeah, for example, string, and comma position, for example.
Why is it giving me those weird autocompletes?
I think it completes for the form and not for the property.
Well, that's wrong. So that's another bug.
I'm not sure it can do that.
Well, it can do anything.
And so you see that's the sort of thing. And some people might say,
completely stupid. What it did there in that particular case, that's not completely stupid.
Mm-hmm. No, just the first one is an alternative, basically, and the second one is the classic.
Right. But again, I want to say this should be analogous to what happens with entity value. All right, I need to go. All right, we didn't manage to de-experimentalize all that much, but I think we made some interesting progress on a bunch of deeper issues. And Raj, with respect to these de-experimentalization meetings, I mean, I think they are readily predictable which ones are going to go easily and which ones are not. I mean, I could have told you, looking at the agenda for this one was not going to be a rubber stamping type meeting. And I can tell you, with respect to this,
I mean, after this, all the other areas that are remaining are areas which currently are recommended to stay experimental. So do you want me to?
What's an example?
Give me 1 second.
Well, I think it's worthwhile to sort of kick the tires of these things because, the goal is to gradually move them towards, final polished form. And we don't get to do that unless we, look at them and change them. I mean, like for example, the neural net stuff, we will introduce, I'm sure, some higher level understanding of what's going on, and that will allow us to feel confident about the experimentalizing them.
Right. And I sent you the agenda for the functionality that's supposed to be experimental.
Why the heck is audio experimental? Why is this? Oh, I see. There are a few bits and pieces there. I don't think audio capture needs to be experimental. Ask, I have no idea why that needs to be experimental. I don't know why that needs. No, these are worth looking at. There's no reason that's. I mean, why? Why? For cookie store.
Don't have any comments other than those.
Okay, we through these. Does not need to stay experimental, in my opinion. I don't know why this would be experimental. There's nothing experimental about it. Seems fine.
Do you want me to stick the text search with these functions for the next meeting?
Yes, I think the conclusion with text search is going to be that we review it a bit. I doubt we're going to be able to de-experimentalize it. Okay, but I think it is worthwhile to review it, unless we decide, Matt, that's for you, that we're simply going to look at that in the next text search review meeting. When is that supposed to be, Matt?
I'm not sure. These meetings took a bunch of your time this week, and I'm on PTO for a week and a half now.
Okay. All right. Could whoever's making it themselves? Okay. In any case, no, we need to look through these. There are plenty of things here which do not need to stay experimental. Okay, I'm going to hang up. Thank you, everybody. Thank you to people on the live stream. Nice comments today. Much appreciated.